Welcome to the Transparent Math Reasoning LLM, a groundbreaking model built using Gemma2, LoRA SFT, and GRPO Reinforcement Learning. This innovative approach aims to enhance the clarity and reliability of mathematical reasoning in AI. Modern LLMs can solve math problems but often fail to explain how they reach the answer. The reasoning is unstructured, inconsistent, and often hallucinated. Our goal is to build a model that provides clear, structured, and verifiable reasoning, essential for trust and transparency in AI. We face three major challenges: unreliable reasoning, hallucinations, and lack of a standard format. LLMs often produce reasoning that skips logical steps, explanations that contain fabricated facts, and inconsistent output structures, making verification difficult. Our solution involves building a transparent math reasoning system using Gemma2. The process includes two stages: LoRA SFT for structured reasoning and GRPO RL for enhancing correctness and format consistency through a custom reward function. The system architecture consists of several key components: math dataset, preprocessing, LoRA SFT, GRPO RL, and the final model. Each step is crucial in developing a transparent reasoning model that is both reliable and interpretable. The workflow pipeline includes dataset creation, tagging, tokenization, SFT training, RL training, evaluation, and export. Each step is meticulously designed to ensure the model's transparency and accuracy in reasoning. Our dataset design uses a strictly formatted JSONL structure, wrapping reasoning and answers in special tags. This approach ensures predictable learning and prevents missing reasoning steps, crucial for structured learning. Preprocessing involves tag insertion, sanitization, tokenization, embedding resize, and filtering. These steps clean and format data, support new tokens, and remove corrupted samples, ensuring high-quality training data. We utilize LoRA for lightweight fine-tuning, focusing on learning the reasoning format. This stage is crucial for teaching the model the grammar of our structured output, preparing it for reinforcement learning. Reinforcement learning with GRPO focuses on correctness, tag enforcement, conciseness, and eliminating hallucinations. It verifies mathematical accuracy, enforces structural tags, penalizes verbosity, and detects fabricated steps. The reward function is designed to incentivize accuracy, proper tag usage, and clarity while penalizing incorrect answers, missing tags, and verbosity. This system ensures the model's output is both correct and concise. Our project leverages core frameworks like Gemma2 and Hugging Face transformers, alongside platforms such as Google Colab and Kaggle kernels. These tools are essential for developing and deploying our model efficiently. The model produces well-structured reasoning, clear step-by-step solutions, and a consistent format with zero hallucinated tags. These outcomes demonstrate high interpretability and accuracy, crucial for reliable AI reasoning. We tackled challenges like hallucinations, GPU memory, RL instability, and dataset noise through tag-based structure enforcement, LoRA tuning, custom reward shaping, and strict preprocessing. These solutions ensure model stability and reliability. In conclusion, we built a transparent, reliable math reasoning model by combining SFT for structure and RL for accuracy. The result is a deployable model that explains its work, paving the way for trustworthy AI reasoning. Future improvements include expanding the dataset to integrate complex multi-step reasoning problems, deploying the model as an interactive chatbot, and adding a self-verification layer for double-checking its logic. Thank you for listening. We invite any questions or feedback you may have about our presentation in the Transparent Math Reasoning LLM. Here are the sources for the images used in this presentation, providing visual context and support for our discussion on Transparent Math Reasoning LLM.